Hello everyone, welcome back to my channel codeWithKhan. So if you are new to my channel, please subscribe to my channel. Let's see today's LeetCode problem 1415. The kth lexicographical string of all happy strings of length n. It is medium marked. Let's read the question. A happy string is that consists of only characters A, B or C, and s of I should not be equals to s of I plus 1 for all values of I from 1 to s dot length minus 1. So what it is saying, a happy string is nothing but a string that only contains A, B, C. Only these three characters are allowed, and s of I should not be equals to s of I plus 1. That means no adjacent character should be equal. So no adjacent chars should be equals. So that means if you take an example A, B, A, so it only contains A or B or C and no adjacent characters are equal. So this is considered as happy string of length n. So n is nothing but here of length 3. So this is a happy string of length 3. And if you see one more example, this B, A, A, so this is not a happy string. Why? It only contains A, B. The first condition is true, but if you see these two adjacent characters are equal, so this fails the second condition, so it is not considered as a happy string. Okay, that is the example. So let's read the question. Given two integers n, k, consider a list of all happy strings of length n sorted in lexicographical order. We need to return the kth string of the list, and or we need to return empty string if there are less than the k happy strings of length n. Okay, what it is saying, so we need to generate, so they are giving n and k, so n is nothing but length of the happy string, so we need to generate all happy strings of length n, and we need to return kth string from that list. So we need to sort that list in lexicographical order, and we need to return the kth string from that list. And sometimes if we generate all the happy strings of length n and we got 10 strings, and he is requesting for the 12th string from that list, so it is not possible, right? So at that time we need to return an empty string. Okay, let's read the constraints. Constraints are n is less than or equals to 10 and k can be less than or equals to 100. Okay, these are simple. Let's continue. Let's take one example. Let's take n is equals to 3 and k is equals to let's take as 2. Okay, so we need to generate all happy strings of length 3, and we need to get the second happy string from that list, lexicographical order list. Okay, now we need to generate happy strings, all happy strings of length n. So length n means we have 3 positions. Okay, we have 3 positions, and what are all the allowed characters? Only A, B, C. Okay, what is the condition? No adjacent characters should be equal. That means our current character should not equals to our previous character. That is the condition here. Okay, what are the allowed characters in the first positions? What are the characters we can place in the first positions? So we can place A, B, C, because we have no restriction here, because we can place A, B or C because we don't have any prior position to this, so to compare it with if it matches with our previous character or not, so we can place A, B or C. So there are 3 possible ways to place the characters here. Okay, what are the allowed characters in the second position? In the second position we can place, it depends on the previous character. How? If we placed A before, we can place B or C. If we place B before, we can place A or C. If we place C before, we can place A or B. So here we have only 2 options. It depends on its previous position. So we will be going to have only 2 options here, and either it depends on the A, B or C. If it is A here, we can choose B or C, or if it is B here, we can choose ARC. If it is C here, then we can choose ARB. Okay, and what about this position? The third position is also same. How? It depends on this previous character. If we choose B here, then we can choose ARC, or if we choose C here, then we can choose ARB. What about this position? This is also same. It depends on the previous character, and here also we can generate two characters. Okay, so what are the total possible happy strings? Which is 3 cross 2 cross 2, which is 3 to the 6, 6 to the 12. So there are 12 happy strings possible of length 3. Okay, what is the formula? How we are finding that? So this one is constant, so we can generate, there are 3 possible happy strings in the first position. What about the second position? In the second position, there are only 2 options we have. Either we can choose 2 characters. It depends on the previous character, so we should not choose the previous character. Okay, because no adjacent element should be equal, and it depends on the how many remaining position we have. So we already selected one position. There are n minus 1 positions will be possible. So n minus 1 to the power of n minus 1. So there are total 3 cross 2 to the power of n minus 1 happy strings we can generate. Okay, so this is the key observation. Now let's proceed how we can do this. So we can use recursive backtracking algorithm to generate all happy strings. Okay, how? So we already know that allowed characters are A, B or C. Okay, what we'll do is we'll take a empty string called, let's call it current string, which is equals to empty. Okay, what we'll do, we will iterate through this list, and we'll append each time we'll append a character to our current string. So before appending, we'll confirm if it has any character before, and we need to compare it with our current characters. They should not be same. So that is the simple condition. What we'll do, we will let's take our current character is empty for example now. So this is empty. So what we'll do, we have 3 options. Either we can choose A or B or C. So let's go with A. So we have A. So if we choose A, so what are the other possible characters we can choose? We can choose either B or C, right? Either we can choose B or C. So if you choose B here, what are the possible characters here? You can choose C. Sorry, lexicographically we need to go. We can choose A, or we can choose A, B, C. So these are the initial 2 happy strings we found. Okay, what about this one? So if we choose A comma C, what are the other possible characters? We have ACA and AC and then B. So these are the next 2 possible characters in the lexico. These are the lexicographical only, because we are traversing in this direction from A to C. So it is guaranteed that it will generate only characters in lexicographical order. Okay, so we have generated all the happy strings that starts with A. Okay, so like this we can generate all the happy strings for strings starting with B and strings starting with C. Okay, I'm not writing all the full binary tree for this, all the tree for this one. So but this is the whole idea. Okay, now let's see the algorithm. How we can approach this. So what we'll do is we will take a backtrack method. Okay, and what we'll do, we will pass the current string to this method. Okay, we'll pass current string to this method. Current is equals to empty initially. Okay, what is our base condition? Base condition is if our current character dot length is double equals to n. N is length of the happy string. So if it is equals, then that means we found a happy string. So what we need to do, we will take a resultant list and we'll add that current string to the result list. Okay, and we will directly return from here. So we have found one happy strings. So that is the base condition for our recursive method. Okay, what is the next thing we need to do? We need to if current dot length is not equals to n, that means we did not find any happy string yet now. So we need to append a characters. So how we can append? So we have what are the allowed characters? We have A, B, C list. So what we'll do, we'll iterate through all these characters, chars ch in, let's take it as allowed characters, in allowed characters. Let's take string only here, should not equals for each character in A, B, C. Okay, so what we'll need to do, we need to append our we need to iterate through all these characters, and we need to append, each time we need to append a character to the current string. So what we'll do, we'll append current is equals to current plus ch. Okay, so we are appending, but what is the base condition here? So the condition is the current character should not be equals to the previous character, right? So this is our condition. We need to check that. So we can check that if, so we need to check the previous character. We can check if our current dot char at previous character. How we can find the previous index? We can find current dot char at current dot length minus 1 is should not be equals to ch. So then only we can append, right? Then only we can append. And we are accessing the index here, so we need to check the current dot length should be greater than equal greater than 0, and then current dot char at current dot length minus 1 should not be equals to the our current character. So that means previous character should not be equals to the current characters. Then only we can append this. So let's place this inside the current if condition. Okay, so once we append the ch, then we need to call the recursive method backtrack with the this current character, current string. Okay, that's how we can append all the characters based on this condition. Previous character is equals to the current character or not. Based on that, we can append the characters, and we can proceed for the we can call the backtrack method recursively. And if the current dot length equals to n, then we will add that current string to the result list. Got it? And that's it. And at the end, what we'll do, we'll check if our result dot size. So once we generated all the characters, we need to check if result dot size is less than k. Less than k means if it requires the kth string is not possible to get it from the result string, then we'll just return empty string. Otherwise we'll return result dot get of k minus 1. So that's it, we'll write in the main method. Okay, now let's take with one example. Okay, so initially what we'll do, we'll take a current method. Let's take current is equals to empty and n is equals to 3, k is equals to 2. Okay, I will take the simple one. I will take k as 2 only. Okay, let's take initially our current is empty. So what is the condition? Current dot length is equals to n? No, it is empty, 0. So 0 is not equals to n. So we'll come here and we'll see we need to iterate. So initially we have a, we need to check this condition. Current dot length is greater than 0? No, current dot length is 0 only. So we'll proceed further and we'll add we'll add this character to the current string. So what we'll do, we'll add a character and we'll proceed further. We'll call the backtrack method. Now we got a. Now we'll check if a dot length is double equals to n is nothing but 3 here. Okay, dot length is double equals to 3? No, because we'll proceed further and we'll iterate through this loop, and again we got character ch and we will be iterating from a to b again. So now if we check current dot char, current dot length, so if we simply if we see is our current character is a, Is this equals to the previous character? True, right? Previous character is also A. So we'll skip this one and we'll proceed further. If we proceed, we come to B. And now we'll check if this B is equals to previous character is A. So which is not true. So we'll proceed further and we'll add this current characters to the our current string. So now string becomes A, B. Now we'll call the backtrack method again with the AB string. So now we got AB. So is AB dot length is double equals to 3? No. So we'll come to the for loop again. We'll again traverse from A to C. Now we'll check current character is A. Is our current character is equals to previous character? No, right? Which is B is not equals to A. So we'll proceed further and we'll add current character is A to the our current string AB. Now string become ABA. Now ABA dot length is equals to 3. True. So now we'll have a result array and we'll append this ABA to that list. Okay, and now we found a happy string of length 3. Okay, now we'll directly return back to the for loop. So what is the current string in our recursion stack? We have AB here. We have AB. And now this character is completed. Now we'll proceed further for B. So is this B is equal as previous character? B is true. So we'll proceed further. We'll skip this character and proceed further for C. So C is equals to previous character? No, right? So we'll append the current character C to the current string. Okay, now string become ABC. Now we'll proceed further for backtrack method. Now backtrack method got ABC. Now ABC dot length is double equals to 3. True. So we'll add ABC to the list and we'll return from here. Now we back again and we come to the recursion stack, and now here also loop is completed, and so we'll go back to the recursion stack where it is being called. So now when we go back, that here the current string will be A, and with B we completed. Now what is the current character, which is C? Now current character is C. Will come for backtrack method with AC. Now we'll check if AC dot length is equals to 3 or not. So like that we will proceed to generating ACA and then ACB and then ACC is not possible because these two are same. So like that we'll generate ACA and ACB with the starting character as A, and when it is ending then we'll start for B happy strings which is starting with B. So like that we will form. But there is one improvement we can do here. So while generating the happy strings, what we can do is, so here itself we can mention somewhere like if result dot size is greater than or equals to k, right? If result dot size is greater than or equals to, that means if we already found our happy string that is requested, then we can directly return from here, right? Directly we can return from here and we can return the kth string. So we don't need to generate the all 3 cross 2 to the power of n minus 1 happy strings. For example, n is equals to 3 cross 2 cross 2, which is 12 happy strings are possible, and I am requested only for the second string, right? I don't need to generate all 12 strings. I can only find ABA and ABC. So I found ABC, which is which is already generated. So we can directly return from there and we can return the ABC string. Got it? That's it. Now what is the time complexity for this approach? Time complexity is, as I previously mentioned, we are going to generate 2 to the power of n minus 1 strings. So it would be 3 to the power of n minus 1, and this is the constant, so it would be big O of 2 to the power of n. Got it? What is the space complexity? Space complexities we are using is resultant list for storing the happy strings, and we are not storing all the happy strings, right? We are only storing k happy strings. So it would be big O of k. Otherwise we would be storing 3 to the power of n minus 1 happy strings, but we have added a string condition to check like terminate this recursion when we found the requested kth string. So for that reason it would be big O of k. Got it? Now let's try to write code for this. Let's take 2 global variables. One is to store the results, list of strings. So here we will store the happy strings. We'll take it as results. Then another one is to store the allowed characters. So let's take it as cats. So here we will store the allowed characters. Now let's initialize this. Result is equals to new array list, and then cats is going to be new character array. Here we will store only the allowed characters, which are A, B, and then C. So only these are allowed characters for generating the happy strings. Now what we'll do, we'll call the backtrack method. Okay, so initially we'll start with the empty string and we'll pass n and k also, since we are using these n and k variables in our method. Okay, now let's write this backtrack method first. Public, so we are not writing anything, so we will be using void, public void backtrack, and then it will take string. Let's take as current string, and then we'll take int n and int k as it is. Now what is our base condition? Base condition is if our current string dot length becomes n, then we'll add that current string to the result list, right? So we'll check if our current dot length is double equals to n, then what we'll do, we'll add our current string to the result dot add our current string, and then we'll return from here. Okay, and then what is the one more condition I have set to improve the performance? I said if our result dot size becomes greater than or equals to k, right, then we'll stop here itself, right? We will not generate all the happy strings, we'll stop it here and we'll return from here. Okay, now what is the now let's try to iterate the allowed characters and we'll generate the strings. Okay, what we'll do, we will iterate for each character ch in the cats, for each character ch in the cats. So what is the condition? So the current character ch should not equals to the previous character in the current string. That is a condition. So here we have two cases. One is if our current dot length is 0, then we don't need to check the previous characters. Otherwise we need to check. How we can check? Current dot caret of current dot length minus 1 should not be equals to the current character ch. Okay, so if it is current dot length is 0, then also fine. Otherwise we need to check the current character should not equals to ch. Then we'll call the backtrack method by appending the ch to the current character, which is current plus ch, and then we'll pass n and k as it is. So that's it, we can generate the all happy strings. Now we are done with the backtrack method. Now let's come here. Now if we generated the all the strings, but we are not able to find the k in the result, so then we'll check if result dot size is still less than k, then we'll just return the empty string. Otherwise we'll return result dot get of k minus 1. Okay, that's it. Now let's try to run this code. Yeah, it is accepted. Now let's try to submit this code. Yeah, it is accepted. So if you like my content, please do like, share and subscribe, and if you have any questions, comment. Thank you. Bye.